We now extend multiplying polynomials to multiplying a binomial times a trinomial, but honestly this could be extended to any type of polynomials that you're multiplying together. In this example we have the binomial x minus 2 times the trinomial x squared plus 3x minus 4. To multiply these types of expressions together, we have to distribute everything in the first polynomial by each term of the second polynomial. So that is, we would say x multiplies by each of the three terms in the trinomial, and then we distribute negative 2 to each of the three terms in the trinomial. So x times x squared is x cubed. X times 3x is 3x squared. X times negative 4 is minus 4x. Now we distribute negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times 3x is negative 6x. And negative 2 times negative 4 is plus 8. Then we add like terms together to get x cubed. 3x squared minus 2x squared is 1x squared, or just x squared. Minus 4x minus 6x is negative 10x, and then plus 8. So as long as each term in the first polynomial gets multiplied by each term in the second polynomial, you will have done your multiplication correctly. Now let me show you how this extends to some special products, specifically the sum and difference of cubes. Now you don't know that's what it's called until you see the result of this particular expressions. So if we have x plus 4 times x squared minus 4x plus 16, we're going to distribute x times x squared to get x cubed. X times negative 4x, it's negative 4x squared. Right, remember to add your exponents on the x's. X times 16 is plus 16x. Now distribute the positive 4. 4 times x squared is plus 4x squared. 4 times the negative 4x is negative 16x. And 4 times 16 is plus 64. So when we add these expressions together, we get x cubed. Notice the x squared terms add to 0. The x terms add to 0. We just have plus 64. So x cubed plus 64 is this result, and that is called the sum of cubes, and I'll explain that more in just a minute. Let's look at this example. X minus 5 times x squared plus 5x plus 25. If we distribute the x to get x cubed, x times 5x is 5x squared. X times 25 is plus 25x. Negative 5 times x squared is negative 5x squared. Negative 5 times 5x is negative 25x. And negative 5 times 25 is negative 125. So again, we combine like terms to get x cubed. The x squared goes out, the x term goes out, and we have minus 125. So this product yields what we call the difference of two squares. So notice that we have a binomial and then this trinomial. Notice how the trinomial relates to the binomial. The binomial terms are x and 4. The x squared is the first term squared. Notice the 16 is 4 squared. And the middle term is a product x times 4, but the sign is the opposite of what it was to begin with. Same thing happens in the second example. X minus 5, x squared plus 5x plus 25. Notice the x squared gives us x squared. If we square the 5, we get 25. And then if we multiply x times 5, we get 5x, but again the sign is changed. And so this product is written like this. We have a plus b times a squared minus ab plus b squared will give us a cubed plus b cubed. And then if we have something in the form a minus b times a squared plus ab plus b squared, we get the difference of cubes. And that's going to come up when we have to factor. That is when we reverse, starting with a polynomial, figure out what we have to multiply to get that. But these are just some interesting products that yield some pretty cool results.